In 2023, a New York lawyer submitted a legal brief to a federal judge packed with precedents. It cited cases like Varghese v. China Southern Airlines. There was just one problem. That case didn't exist. The lawyer had used ChatGPT to write his brief, and the AI simply invented the cases, the judges, and the court dates out of thin air. A year later, Air Canada deployed an AI chatbot to handle customer service. When a grieving passenger asked about bereavement fares, the bot invented a generous refund policy that contradicted the airline's actual rules. The customer sued, and the court forced the airline to pay up. These failures occur because business leaders treat large language models like omniscient databases filled with cold, hard facts. To understand why an AI confidently lies to a judge or a customer, we have to look under the hood. In his book Bridge the Gap, technology executive Sriram Gopalan translates how these software systems actually operate behind the scenes. Assuming an AI actually knows anything is a phenomenally expensive mistake. To use this technology safely, you have to understand its mechanical flaws. This diagram shows exactly how a large language model operates. It functions as a massive, highly complex version of the autocomplete on your phone. It is a spicy autocorrect. If you prompt the engine with "the capital of France is," it doesn't look up a map. It calculates the statistical probability of the next word. It chooses Paris because there is a 99% chance that word follows the phrase in its training data, whereas London or baguette sit at fractions of a percent. This chart illustrates the trade-off. Because the engine predicts words based on patterns rather than retrieving facts, it is phenomenal at creative writing, summarizing documents, or drafting polite emails. But it is incredibly dangerous when you need a single, correct answer to a math or history question. The system suffers from two structural flaws. First, it has no short-term memory. Its brain resets with every new conversation. Second, it has zero internal mechanism for fact-checking. It will confidently output the wrong word simply because it mathematically fit the pattern. The engine is designed to prioritize sounding plausible over being factual. Letting it speak directly to your customers without a safety net invites a lawsuit. This flowchart breaks down the two phases of an AI's lifecycle. Phase 1 is training, which is like sending the model to an expensive university. Companies like OpenAI spend hundreds of millions of dollars and several months feeding the entire internet into the system. But once that training process ends, the model is frozen. If a company finishes training its AI today, that AI will know absolutely nothing about the events of tomorrow. That brings us to phase 2, inference. This is the job. It is the phase where you actually send the model a prompt and it generates an answer. Unlike the university phase, inference takes milliseconds and costs fractions of a cent. This is what your engineers are doing every day when they build an AI application. They are relying on a brain that is incredibly fast, but completely frozen in the past. As a business leader, you are not going to spend millions training a model from scratch. Your entire operational risk lies in how you manage that fast, cheap inference phase. This diagram illustrates the central engineering problem. If the AI's memory is frozen, it doesn't know your company's current Q4 sales data. Letting the AI guess in this scenario is a mistake. It will hallucinate a highly plausible, completely wrong $10 billion figure. The industry standard solution is called RAG, Retrieval Augmented Generation. Think of it as an open book exam. Instead of relying on the AI's frozen memory, the RAG system intercepts your question. It searches your private company database, pulls the exact Q4 sales PDF, hands that document to the AI, and instructs it to answer based only on that text. The second necessary guardrail is a setting called temperature. This is a dial that controls the model's creative risk. Set it to 0.0, and the AI acts like a strict accountant, picking the most statistically likely words every single time. Sweep it up to 1.0, and it acts like a creative director, taking wide, varied guesses to produce novel ideas. If engineers leave that dial at 1.0 for a customer service bot answering strict billing questions, the model will invent policies just to sound interesting. RAG implementation and temperature settings are the core business decisions that separate a useful tool from a high-stakes lawsuit. The New York lawyer and Air Canada cases demonstrate the danger of treating an AI like an oracle. SynfD requires a RAG architecture and a zero temperature setting to ensure the model stays grounded in your actual policy documents. The modern corporate playbook prioritizes renting existing intelligence and investing the remaining budget into building strict data pipelines to control it. You now have the vocabulary to interrogate your own engineering teams. You can ask exactly how your models are grounded and what temperature they are running at. And for a complete guide to decoding the rest of your software stack, check out Sriram Gopalan's book, Bridge the Gap. Sustainable technological power requires strictly managing an AI's mechanical limitations. By bounding its probabilistic nature, you transform a risky, spicy autocorrect into a reliable business asset.